Alright guys, so what we're going to be going over today, and these are the notes for January 10th. And what we're going to be going over today is simplifying radicals. Because I know when we were doing completing the square, y'all had a tough time just writing your final answer at the end, and that mostly came from because we don't know how to simplify things like radicals or equations like these that have radicals in them. So I'm going to use this time to just go over how to simplify radicals. So the first one, or to simplify radicals first of all, is the process of finding any perfect squares that can go under the number in the radical. And what I mean by perfect squares, here's some examples, like 4, 16, 25, 9. So a perfect square is a number that you can take a whole number and multiply it by itself to get these numbers. Those are perfect squares, so just a little review. So again, when we simplify radicals, first ask yourself, can any perfect squares go into this number? So we know that 20 is not a perfect square, but what's a perfect square that can go into 20? That's going to be 4. So you can rewrite this radical as 4 times 5, because that's how many times 4 can go into 20. So from here, what we're going to do is the perfect square under the radical, we're going to take the square root of that, which is 2. So once we've taken the square root of this number, we can put it on the outside of the radical. And we know, don't forget your plus or minus on every single one. And we know that 5 is not a perfect square, and there's not any perfect squares that can go into 5, so we're going to leave that underneath the radical. And that's how we would simplify square root of 20. Plus or minus 2 square root of 5. Okay, so for the next one, square root of 180, we think of perfect squares that can go into 180. And I know that, let's see, 9 can go into 180, right? So 9 times 20 would be 180. But then we know that, again, 20 has a perfect square root of 4. So we could rewrite 180 as 9 times 4 times 5. If you want to check that, you can plug it in your calculator. 9 times 4, 36 times 5 would be 180. Okay, so now we see 2 perfect squares underneath the radical. And this perfect square is going to be 3, so we can go ahead and bring that out. This perfect square is going to be 2, we can bring that out, and we'll put it in parentheses. And then the 5 we'll have to leave underneath the radical. So now the two numbers on the outside of the radical, 3 and 2, we can multiply together. So this would be plus or minus 6 square root of 5. Alright, on this one, a perfect square that can go into 212 would be 4. And then 212 divided by 4, that's going to be 53. Alright, and we know 4 is a perfect square, so we can bring that on the outside. And 53, there are no perfect squares that can go into 53 or divide into it evenly, so we can just leave it underneath the radical. Okay, the next few I'm going to go through quickly. If you would like to pause the video during, you can just pause it and then go back if you have questions. Alright, so 2 square root of 50. Alright, this one has a number on the outside, so it's kind of different. So all you'll do is leave the number 2 on the outside. Let's break this up. We know 25 can go into 50, and that's a perfect square. So now square root of 25 is 5. We can bring that on the outside with the 2 and leave this 2 underneath the radical. So now when we multiply this together, that'll be plus or minus 10, 2 times 5, square root of 2. Alright, let me zoom in some. Okay, so now square root of 74, and if you can't figure out if any perfect squares go into it, you'll start with the number 4, the smallest perfect square, or actually 1's the smallest perfect square. But can 4 go into 74? No. Can 9? No. Can 16? No. Can 25? No. And if you try out a bunch of perfect squares, you'll see that no perfect squares can go into 74. So this one cannot be simplified, so we'll just put plus or minus 4 square root of 74. Alright, now we have ones with a negative under the radical, and we know we can't have negatives underneath the radical. And what this does is we can break it up to take the negative away and make this negative 1 times 16. And we all know the square root of negative 1 is I. And we know the square root of 16 is 4. So now we won't have anything underneath the radical. Always make sure to write your real number first, which is going to be 4. Square root of negative 1 is I. Over here, same thing. The square root of negative 81 is going to be, or just positive 81 would be 9. Square root of that negative 1 would be I. Alright, notice how 16 and 81 are perfect squares. Now we have a negative 48, where 48 is not a perfect square. So we're going to have to break this one up. And we can make this negative 4 times 12. 12 has a perfect square, so 4 times 3. And again, you can check this. 4 times 3 is 12. 12 times negative 4 is negative 48. The reason I'm breaking it up into 3 numbers, I pulled out the 4, and so 48 divided by 4 is 12. Well, 12 also has a perfect square in it, which is 4. So I'm just breaking it up into 3 numbers. You could break this up into negative 16 times 3. Either one would be correct. Alright, so right here, the square root of negative 4 is going to be 2i. Square root of 4 is going to be just 2. Square root of 3 is not a perfect square, so we'll leave it underneath the radical. So now 2i times 2, that'll be plus or minus 4i square root of 3. Alright, square root of 7 cannot be simplified because there's no perfect squares that go into it, but we need to get rid of that negative. So we'll break this up into negative 1 times 7. So the square root of negative 1 is going to be I. And then the 7 we'll have to leave underneath the square root. Alright, 3 square root of 9. Again, leave the 3 on the outside. And let's go ahead and break this up. We know that 9 is a perfect square. We know that negative 1 is a perfect square, so we'll break that up. So this way we'll have 3. Square root of negative 1 is I. Square root of 9 is 3. So when we multiply all these together, we'll get plus or minus. 3 times 3 is 9. Bring down the I. Alright, on this one we have 2. I can break this up into negative 1 times 16 times 5. So the square root of negative 1 is I. I got the 2 here from just bringing it down. Square root of negative 1 is I. Square root of 16 is 4. Leave 5 underneath the radical. So if we multiply everything on the outside of the radical together, that'll be 2 times 4 is 8. Times I would be plus or minus 8i. Square root of 5. Alright, so that's just a review of simplifying radicals. Now we're going to get into solving for x. And these are kind of what you get when you get to the end of your completing the square and y'all have trouble solving for x. So we'll go over how to do that at this point. The first thing we're going to do is go ahead and simplify the radical before we even worry about the left side of the equal sign. So let me just bring down x plus 2, leave that alone. Now the square root of 18, what's a perfect square that can go into 18? That'll be 9. How many times? 2 times. So from here we would just take the square root of 9. That's going to be plus or minus 3. So we'll have x plus 2 equals plus or minus 3. Leave the 2 underneath the radical. Alright, from here we need to get our x by itself. Well, if we look at this side of the equal sign, we see that we need to get rid of the 2. So how would you get rid of the 2 in this equation? You would just have to subtract it and move it to this side. So instead of setting up your 2 cases, if it's an ugly radical like this, an irrational number, this is what I suggest doing. You can just do x equals, it's going to be negative 2 because again we had to subtract it to move it to that side. So it'll be negative 2. Then just bring down this term, plus or minus 3 square root of 2. Notice how our x is on a side by itself like we wanted. You can't really simplify any of this, so you can just leave it. Alright. So for this equation, let's go ahead and simplify this side first, just like last time. So x minus 6, we'll leave that alone. Square root of negative 6, there's no perfect squares that go into 6, but again, we can take out the negative by putting plus or minus. Square root of negative 1 times 6. We know the square root of negative 1 is I, and like I said, we can't simplify 6. Oops. So we'll just leave it as plus or minus I, square root of 6. Now to get x by itself, all you have to do is add 6 to both sides. So we get x equals positive 6, then the plus or minus I square root of 6. Because we can't combine these. One has a radical, one does not. Also, this is a real number, this is an imaginary, so we can't combine them. Alright, moving on. So again, leave this the same. We'll come back to it. And let's go ahead and simplify the square root of 72. Also, I'm leaving 3 on the outside of the radical. So the square root of 72 has a perfect square of 9 inside of it. How many times does 9 go into 72? That'll be 8 times. Well, we notice that 8 also has a perfect square in it, right? 4. So let's change this 8 and let's just do 4 times 2. So 9 times 4 is 36. 36 times 2 is 72. So this is the same equation. Alright, so we'll have x minus 1. I'm going to leave the 3 on the outside. Also, the square root of 9 we know is 3. Square root of 4 is 2. And then we're left with square root of 2 on the inside because we can't take the square root of it. So now let's clean this up. We'll have x minus 1 equals, and then don't forget your plus or minus. 3 times 3 is 9. 9 times 2 would be 18 square root of 2. So now we've simplified this. Now we have to get x by itself. So from here, all we're going to do is add 1 to both sides. So we'll get x equals 1 plus or minus 18 square root of 2. Alright, moving on. So this one we notice that 100 is a perfect square, but we also have that negative 1 that we have to bring out. So we'll just do it separately. So the square root of negative 1 is I. The square root of 100 is 10. So together it would be 10I. So we have x plus 10 equals plus or minus 10I. And now to simplify, we would just subtract 10 from both sides to get x by itself. We'd get negative 10 plus or minus 10I. Alright, moving on. So this one, I meant to put a parentheses around the 16 on this side as well. But that's okay, we'll just go from there. So we'll have x minus 4. Alright, so this one's kind of tricky. We have a radical on top, not on bottom. So all you have to do is take the square root of 16, because that's the only thing underneath the radical. And the square root of 16 we know is plus or minus 4. And I'll go ahead and bring out the plus or minus out here, over 4. Okay, so now we can simplify this by doing 2 times 4, that's going to be 8. 8 divided by 4 is going to be 2. So we have x minus 4 equals plus or minus 2. See how this one's different because we have ugly numbers up here. We have irrational and complex. This one's just whole numbers, so I do want you to set up 2 cases. So the first one, it would be x minus 4 equals a positive 2. X minus 4 equals a negative 2 for the second one. And then you'd solve for x in each one. So this one you'd have to add 4. And 4 plus 2 is 6. This one you would have to add 4 to a negative 2, so 4 minus 2 would be 2. Okay, so on this one, we have to simplify the square root, or 4 squared root of negative 63. So let me leave that alone. So, the perfect square that can go into 63 is going to be 9. So we can break this up into negative 1 times 9 times 7, because that equals negative 63. And now we can take the square root of these two, so we'll have x minus 1 equals 4. Let me put a plus or minus out front. Go ahead and do that. Square root of negative 1 is I. Square root of 9 is 3. Then we have 7 underneath the radical. So we'll have x minus 1 plus or equals plus or minus 4 times I times 3. That is going to be 12I square root of 7. And now to simplify, just add 1 to both sides. We'll have x equals 1 plus or minus 12I square root of 7. Alright, 2 more. So this one we have to find or simplify the right side first. So the square root of negative 4 is also going to be 2 plus or minus 2I over 2. And now we can simplify this even further because we know 2 divided by 2 is just 1, right? So that can cancel out and we'll have 1I, or just I. Plus or minus I. Now solve for x, so plus 2 on both sides, so we get x equals of 2 plus or minus I. Alright, last one. So on this one, we're going to look at this side and see what we can simplify, but there's no perfect squares that go into 31, and there's not a negative we need to take care of, so we really can't simplify square root of 31. So all we'll need to do on this one is just add 5 to both sides and make sure we put a plus or minus out front. So this will be 5 plus or minus square root of 31 over 4. And that's it.